Hello again, everybody. This is Joseph. Today is going to be about a specification sheet, a chart for batteries, which battery to use. Information given over here displays all the dimensions and specs for the codes of the batteries. As you can see over here, there are categorized, and there are codes for each battery over here, as you see. Now, when you replace a battery, you have to take into consideration the width, the length, the height. Especially if the height is more, it'll be very sometimes difficult to close the hood and short out the battery. So keep these things in mind. So with the proper code of the battery, you have the correct height, width, and length in inches, and this is in millimeters. As you can see, for passenger car and commercial batteries, 12 volts. Now, something to understand a little more complicated, which amp rating? We all know it's 12.6. What about the amp rating? So, we have to take into consideration a couple of things. Weather plays a very important source with batteries. We all know as again the temperature goes down, the chemical reaction of the battery degrades. So at 80 degrees, the temperature is fine for the battery. It's Florida. But at 0 degrees, the temperature is Green Bay, Wisconsin. Cold, 0 degrees. When you crank the battery, you're putting a load on it. The starter, the engine, so when you do that, you expect the battery voltage to go down about 10.5 volts. Anything less than that is not good. So therefore, this is our criteria, 10.5 volts. Now first I'm going to explain there's cranking amps which is at 32 degrees Fahrenheit, which is not in this chart, but this chart gives you the worst case possible, which is cold cranking amps, and that's at 0 degrees. So at 32 degrees, which is cranking amps, we let the battery voltage go down to about 9.6 volts. Because remember, with temperature, the chemical reaction degrades the sulfuric acid. So with 0 degrees, it'll get even worse. So then we let it go down, and I wrote over here to 7.2 volts. Big difference from 10.5 volts. Remember, it gets worse. Green Bay, Wisconsin, right? Home of the Packers. Lambeau Field, frigid, right? Green Bay Packers, they just fired their coach this year. Now, so therefore, there's a rule. And this is not a rule, but it's a recommendation, I would say. We know that an engine is given in liters. So let's say 8-cylinder, 6-cylinder, let's say 5.7 liter is equal to 350 cubic inches. As I wrote over here, and on the title, 1 cubic inch equal 1 amp. So therefore, if 1 cubic inch equals 1 amp of the battery, then 350 cubic inches will need a battery with 350 amps. Cranking amps at 0 degrees, worst case possible. We look at the chart. Many of them are in that category here, 350, but we always go higher. It's recommended to go higher than the rating. So if you need 350, right here, 24R, this one, we could go with this one. Okay? So remember, we can always go more. If you need 400, you can put 500. 500, you can put 600. It's better recommended. But this is the worst case possible at 0 degrees. If you can crank a battery 0 degrees, you can crank it at 80 degrees Fahrenheit. This is the worst case possible. The batteries like 80 degrees, 70 degrees. So therefore, keep that in mind as the rating. So 1 cubic inch equal 1 amp. In this example, 350 cubic inches will need 350 amps. And I say we can use this one also, but we go higher, recommended. This category, reserve capacity. That means at 80 degrees, which is ambient temperature or favorable temperature for the battery. At Celsius is 27 Celsius. So now, when it comes to reserve capacity, that means 25 amps to be drawn from the battery at 10.5 volts. But the trick is, reserve capacity is just what it indicates. It's a reserve. When you crank the engine, you have the alternator working. The alternator charges the battery and takes care of the accessories. Lights, air conditioning, right? Usually around 14.3. What happens if that serpentine belt, which drives the alternator, breaks? Now the alternator will not be working. So the charging system will be inactive. It will not be operational. Now I'm just relying on a good old-fashioned battery. This category tells me how long in reserve I could keep this battery cranking or charging. So 70 to 95 amps. The higher, obviously, the better. So if I lose the alternator, I know I could get around 70 to 95 amps. But you have to turn off the accessories, the lights and other accessories that you have to try to keep it going as much as you can. So remember, this is important and this is important. But always keep in mind, at the worst possible condition, the cold cranking amps, if I can start the battery at 0 degrees with this, I can start it at 80 degrees. That's why they give you this column, the worst case possible. I hope this was very informative, and please subscribe to my channel. I have much more videos about wiring diagrams. My channel name is Automotive Electronic Schematics by Joseph. Thanks for viewing.